So today we're talking about the product and quotient rules. These are going to be a little more complicated. The sum rule from last section is pretty straightforward for finding the derivative of a function plus a function or minus a function. We just get their derivatives separately and add them or subtract them. That's not what we do for the product rule and the quotient rule. It's more involved than that. So first is the product rule. And you can see, I'll highlight the rule right here. You can see it even looks more complicated. And I tell you what, let me just rewrite it like this. Instead of the function notation, let's say if some function is u times v, then the derivative will be u times the derivative of v plus the derivative of u times v. So you get the derivative of one of the functions multiplied by the other function and plus, then you swap them around. All right. So first example, we've got two functions. So 3x minus 1, that'll be our u, and x cubed plus 1 will be the v. So here we go. So we'll take the first function times the derivative of the second function plus, and then swap them around, the derivative of the first function times the second function. All right. And I always call that setting up the derivative or setting up the product rule. Then in the next step, you compute the two derivatives. So for x cubed, that'll be 3x to the 3 minus 1, which is 3x squared. And then the derivative of 1 is 0. Then add derivative of 3x is 3. The constant minus 1, its derivative is 0. And that's times x cubed plus 1. Okay, so the calculus part is over. Now we simplify. And we simplify by removing the parentheses and combining any like terms. Let's see, I'm gonna make my grammar consistent here. Remove. Ooh, that shouldn't be there. Remove the parentheses and combine like terms. All right. So in this case, to remove the parentheses, we'll distribute on the first part, we'll distribute the 3x squared. So 3x squared times 3x is 9x cubed. 3x squared times minus 1 is minus 3x squared. Then distribute the 3, so that's plus 3x cubed plus 3, and that's it. No, that's not it, sorry. We do have a couple of like terms to combine. The 9x cubed plus 3x cubed, we can combine those to get 12. x cubed, and then minus 3x squared plus 3, and that's our derivative. All right. And you may be wondering, or you may not, but would it have been possible before we ever took the derivative, could we just have multiplied the u and the v together first? And the answer to that is yes, you could, and that's fine if you wanted to do that. A lot of times that's easier, but there will come a time when you cannot multiply the two functions together because one might be a polynomial and one might be an exponential function, and you can't multiply those together. But as long as they are polynomials, if you want to just multiply the things together, that's fine. You know, it get the same thing, and it may be less trouble. All right. In problem 2, notice here we're using a different notation. That's the derivative of y with respect to x, but it's the same thing. So I'll take the first function times, you know, I'm gonna pop in this notation too. This is, again, this is just another notation. It's just saying the first function times the derivative of the second function plus the derivative of the first function times the second function. All right, so that's setting up the product rule. Put that up here. And then the next step is to go in and compute the two derivatives. All right, for 8x to the 6, that'll be 6 times 8, which is 48. And then x to the 5th, subtracting 1 from the power. And minus 6 times 4 times x to the 4 minus 1. And minus 9 is a constant, so its derivative is 0. All right, now for the derivative of 3x to the 7, 7 times 3 is 21. Subtract 1 from the power. Derivative of 4 is 0. And then that's multiplied by the other function. So here's what I'm saying. At this point, if we were going to simplify, gosh, we'd have FOIL for the first product, remove the parentheses, some distributing on the second part, and then combining the like terms. It may have been easier just to multiply the original problem. So you could multiply and then take a derivative. In all honesty, probably in this case, that's what I would have done, because I'm still having to do multiplying and maybe even more multiplying, and it probably would have worked out in my thinking, it would have worked out better just to have done that to begin with. Okay. I'll go ahead and multiply this stuff together to get the simplified answer. On the test, I'm not going to give you, because this is very algebra intense. I just wanted to make sure you know the product rule. And I guess, one like this, you probably got some like this in the homework, so which is why it's here. But like I said, for the test, not my typical kind of question. All right, so sorry, I don't even really want to go through all the algebra here. So what I've got what I've got next, like I said, removing the parentheses. This is FOIL. And then over on the right side, distributed property. And so, let's see, 3 times 48 is 144. X to the 7 times x to the 5th is x to the 12. The outer product, 3 times 24 is 72 minus 72. Then x to the 7 times x to the 3 is x to the 10. Inner product, 4 times 48, 16, 176, x to the 5th. Whew. And then 4 times 24 minus 96, x cubed. Whew. Now on the right side, 21 times 8, that's 168. X to the 6 times x to the 6 is x to the 12. 21 times 6, that's 126 minus 126. X to the 10 times x to the 4. I'm sorry, x to the 6 times x to the 4 is x to the 10. And then 21 times 9 is 108. And then x to the 6. All right. Okay. Wow. All right. So like terms, got this one and this one are 12th powers. So 144 and 168. Let's see, 12, 11. I think that's 312, and then x to the 12. I've got a minus 72 and a minus 126 x to the 10. So that's minus 198. Doing that in my head, so that's kind of scary. And then let's see, I've got I guess the rest of them are not like. I've got a 6th degree term, a 5th degree term, and a cubed term. So I'll just copy those down, and I'm going to take them in order. So minus 108 x to the 6th plus 176 x to the 5th minus 9x cubed is your answer if I did all the arithmetic correct there. Okay. Okay. For number 3, now we're going back to a couple of the topics. From last time, the slope of the tangent line, remember that means the derivative. So again, I'll show you the product rule because that's what we're learning here. So I have the first function. I'm going to use that derivative, that other notation because, I don't know, it just sounds good today. The first function times derivative of the second plus the derivative of the first function times the second function. All right, and that gives me x cubed minus 3, derivative of x squared will be 2x, derivative of minus 4x is minus 4, and the plus 1, that's a constant, the derivative is 0. All right, and then for x cubed, the derivative will be 3x squared. the derivative of minus, I'm sorry, sorry, skipped over something. The derivative of the minus 3 is 0, and then that's multiplied by the x squared minus 4x plus 1. Now, if we were just asking for the derivative, we would want to go ahead and simplify that. But we're asked to find the slope of the tangent line at the point -2, 0. So remember, to get the slope at this point, we substitute the x coordinate into the derivative. So I'm going to elect to just go ahead and substitute rather than do all that algebra stuff. Let's just go ahead and substitute right, the way it looks right now. So we'll say m for slope is the derivative evaluated at 2. That's what it looks like. All right, so -2 is cubed minus 3. 2 times -2 minus 4 plus 3 times -2 squared. And the last set of parentheses, -2 squared minus 4 times -2 plus 1. All right, now we're going to take care of all the exponents. -2 cubed is -8. In the next set of parentheses, 2 times -2 is -4. -2 squared is 4. In the parentheses, another -2 squared. -4 times -2 is +8, and then +1. -8 minus 3 is -11. -4 minus 4 is -8. All right, 3 times 4 is 12. 4 plus 8 plus 1 is 13. And now, let's see, 12 times 13 is, I think, 156. 88 and 156. 14. I think it's 244 again if I did all my arithmetic. All right. Okay. Oh, okay, so those are some examples of the product rule. Now we'll look at the quotient rule, and again, you can look at it and see that it's certainly more complicated than anything so far. And again, let's write it this way. Let's let f of x equal u divided by v. And honestly, when I use this rule, I don't do u and v, I use numerator denominator. So that's what I'm going to do. Let's erase this stuff. And get a little more room here. All right, so this is what I do. So this is for a quotient, which is a numerator over a denominator. And the rule for the derivative is the denominator times the derivative of the numerator minus, and then we swap them around, the denominator derivative times numerator. And that's all over denominator squared. All right. So first of all, the derivative of a quotient, that's just a fraction, is another quotient. And in the top of that quotient, it kind of looks like the product rule. It's very similar. There is subtraction. And because there's subtraction, the order that you do these is really important. You can't change the order of stuff. It's got to be the way it looks in the rule. All right. So let's use that for number 4. All right. So I usually do something like this, and maybe just go ahead and put this denominator squared in the bottom. And so here we go. The denominator is x plus 5 times the derivative of the numerator minus the derivative of the denominator times the numerator. All right. And again, I'm not computing any derivatives here. I'm setting up the quotient rule. And in the next step, I do the 2 derivatives that are inside the quotient rule. All right, so the next step is to compute the derivatives. All right, so here we go. Keep x plus 5, and for the derivative of x squared, that's 2x. For minus 4x, the derivative is minus 4. Then subtract. The derivative of x is 1. And remember that sort of shortcut we talked about last time. It's just, you know, once you do some of this, you realize, oh, there's a shorter way to get the derivative of a constant times x is just the constant. All right. So that's 1 times the x squared minus 4x, and still all over denominator squared. Okay, let me go ahead and make this side note. Rarely do we ever do anything with that denominator. Just leave it. There's some, what I call illegal algebra that some people try to do here. I'll just go ahead and mention it. You may think, oh, I've got an x plus 5 in the numerator and an x plus 5 in the denominator. I'm going to cancel those out. But you cannot cancel those because the x plus 5 in the numerator is multiplied by something else. So you can't just cancel it. It doesn't work that way. So that's why I say just leave the denominator alone. Hardly ever do we do anything with that. So again, we're going to multiply. Whoa, hit the expand button. So hang on a minute. Okay, here we go. All right, so this multiplication here is done by FOIL, and on the other side of the minus, we're distributing. And remember that the minus goes with the 1. So we're actually distributing the minus 1. All right, so I'm going to do that. FOIL gives me 2x squared minus 5x. I don't know where that came from. How about minus 4x? For the outer product, plus 10x for the inner product, minus 20 for the last product. Now I'm distributing the negative 1. Minus 1 times x squared, minus 1 times minus 4x is positive 4x. That is still all over denominator. That was squared. All right. And then we'll finish it up by combining like terms. So let me make that note again. We leave the denominator alone, but to simplify, again, we remove the parentheses by multiplying. And then combine our like terms. So we've done our multiplying. We've got a 2x squared, a minus 1x squared, gives me a 1x squared. Actually, the minus 4x and the plus 4x will cancel out, which leaves plus 10x minus 20, and it's all over x plus 5 squared. And that's how we leave it. All right. So like I said, leave the denominator alone, you're done. All right. Okay, here's another one. To practice the quotient rule. So we'll get that started by setting it up. So f prime of x, the derivative, the denominator times derivative of the numerator minus derivative of the denominator times numerator and again all over denominator squared. All right, so set up quotient rule. Next step, compute the two derivatives that are inside the quotient rule. All right, so x squared plus 1 for 2x squared, that'll be 2 times 2 is 4, and subtract 1 from the exponent leaves me x. Derivative of minus 5x is minus 5. For x squared, that's 2 times x. The 1 is a constant, it disappears. And that is multiplied by the other function. All over that denominator squared, which I'm leaving alone. All right. Now I'm in the simplifying part. So again, this is FOIL. This is distributive. And what I'll be distributing over there is the minus 2x. It goes all together. Okay. All right, FOILing gives me 4x cubed minus 5x squared plus 4x minus 5. Distributing to minus 2x gives me minus 4x cubed and positive 10x squared, and still all over that denominator squared, which I'm leaving alone. Okay, and then we'll finish it up by combining like terms in the numerator. So I've got a 4x cubed and a minus 4x cubed. Those cancel out. I've got a minus 5x squared plus 10x squared. Negative 5 plus 10x squared would be positive 5x squared. And there's a plus 4x and a minus 5, and I'm done. All right. All right. So as happens a lot in calculus, you know, the algebra, a lot of times the calculus isn't so bad, but the algebra that goes along with it can be. All right. So that may look just really terrible to you, and maybe it is. It could be a lot worse, but we try, you know, we and I try not to focus on the ones that are very messy. Okay, you may not think that, but it is true. Come on now. Trying to find this point. Oh, it doesn't let me do anything with it. Yeah, okay. All right. Okay, so actually, let me get some space. Here, I feel like I'm going to need more space. Page break. Okay. All right, for number 6. This time we're finding an equation of the tangent line, the graph of the function at the point 2, 3. Okay, so what do we have to do? We have to get our derivative because that's how we get the slope of the tangent line. Then we have to substitute in point slope form to get the line. All right. So we'll do that. We'll get the derivative for the slope of the tangent line. And that's really what we're learning in this section. And again, that's a quotient, so we will start with the denominator times derivative of the numerator minus, swap them around, derivative of the denominator times the numerator. All right. Then compute the two derivatives that are part of the quotient rule. For 3x, the derivative is 3. On the other side, okay, that up down there underneath that. Okay, so minus, now the derivative of x squared is 2x, and the derivative of 3x we just keep. Leaving the denominator alone, and now simplifying, that'll be 3x squared minus 6 minus 2x times 3x will be 6x squared. And again, still all over denominator squared. The 3x squared and the minus 6x squared are like terms. Combining those gives me minus 3x squared minus 6. And that's all over that denominator squared. So there's the derivative. Took a little work to get that. My slope will be the derivative evaluated at the x coordinate of the point. This 2 is the x coordinate of the point. All right. So I'm substituting 2 in the derivative. All right, now 2 squared is 4. I got that twice. Oh, did not do that, computer. That's 4 minus 2 squared. Negative 12 minus 6 is negative 18. And then reducing that gives me negative 9 halves. All right. Now, hopefully you're still listening. And I'm now gonna show you, computer's being weird. I want to show you, you're gonna really like this. It doesn't take away having to know the rules, because you still have to know the rules, but there is a way that your TI 84 can give you that number that I just got without you having to do any of the other stuff. All right, so get that going. All right, so I'm going to go to my calculator. I'm going to clear everything out. And my function is 3x squared of 3x divided by x squared minus 2. Now I can't get to my, come on. I don't know what's going on here. Okay, 3x divided by, in parentheses, x squared minus 2. The parentheses are critical. Be sure all that stuff gets in the denominator. Okay, let me see my window. All right, I'm gonna just get a quick graph by doing Zoom 6 standard window. I want to trace to the point they're talking about, just to make sure so far everything's good. So that's what we're looking at. That we want the equation of the tangent line at that point. All right. So I'm going to the calculate menu. Actually, let me get a picture of this real quick. Okay, let's see. I really don't know what this is doing. Okay, sorry, I know I'm talking to myself. All right, I'm going to the calculate menu, second trace. And item 6, when you see it now, hopefully you recognize that as derivative notation. That's what that is. Sorry. Okay, so I'm going to grab that, dy dx, and it's blinking. It kind of moved around a little bit, but basically at this point you give it the x coordinate that you want, which is 2. So the cursor's blinking, I'm pressing 2, enter, and there is the derivative, negative 4.5, with some extra decimals there at the end. It's just because of the way it's programmed. You know, it's not a computer. It's pretty good, but it's algorithmically programmed, and it's sometimes when it's doing these more difficult calculations, it gets into a bit of a rounding issue. That's okay. We'll take the negative 4.5 as our slope. Okay, so head back over to the really don't know what just happened here. I'll pop in that other screen. That's not it. Okay, so hang on. I need to go back and copy the screens I want. There's one of them. All right. So, assuming I got everything in there that I wanted. All right. So again, in that first screenshot is the graph of the derivative. I chose that's second and trace to get to the graphing calculate menu, and then press here, you just press 2 and enter, and it gives you the derivative, which is the slope. All right, so I got negative 9/2. Obviously, you know, negative 4.5 is okay as well. All right, so that's the slope. Now we need to do the algebra, get the equation of the tangent line. That's y minus y1 equals n times x minus x1. All right, our point 2, 3. So 3 is the y coordinate. I did that. 3 is the y coordinate. The slope, negative 9/2, or if you use negative 4.5, it should be fine. If not, it'll tell you, you know, they want it as a fraction. And then to simplify it, distribute the negative 9/2. Negative 9/2 times x, negative 9/2 times 2. The 2's cancel. And then finally, we'll add 3 to both sides. And that will give me my equation. Negative 9/2 x plus 12 is the equation of the tangent line. And I'm going to do one more thing on my calculator. I'm going to put in y2, I'm going to put that equation, negative 9/2 x plus 12. That's should be, well, that's what we got for the equation of the tangent line. Sure enough, I'm even going to go back and trace to the point 2,3. And the red line is the tangent line that I computed over on the paper. Okay. Let's see where I can bump that. Right here. Okay. There is a way you can get the calculator to give you the equation of the tangent line. That's a little more involved. So I don't want to overload you. So I'm not going to show you that at this point. Okay, then finally, I believe this is the last one. Yeah. Average cost. Is something that is of interest over in the business world, economics. You can have average cost, average revenue, average profit. And for each of these functions, you get by just dividing the original function by x. So cost function divided by x, revenue function divided by x, and profit divided by x. All right. Okay, forgot these are. Didn't really want to give you square root functions. Let me see if I can find something better. I could just make something up, but I'm going to make it up. So hopefully it'll be okay. And I'm not going to use anything real crazy. Okay, let's say C of x is 10,000 plus 8x. And revenue is 12x. We'll make it real simple. Okay. I think your text will also maybe use this notation with the bar over it. But I don't have it up there, so I may be wrong there. All right, so average cost, average revenue, and average profit. All right, so let's just go ahead and get the profit function. Remember, that's revenue minus cost. So P of x, 12x minus so that's 12x minus the cost function. Distributing the negative gives me this function. Then combining the 12x and the minus 8x gives me 4x. So now I've got all 3 functions. Okay, so for the average cost, call it C bar. So that's C of X divided by X. That's 10,000 plus 8X divided by X. Then for the average revenue, we call it R bar, average revenue. So that's the revenue function divided by X. That's just 12X divided by X. Probably should have done something a little different, but that's okay. That's 12. And then for the average profit, that'll be 4X minus 10,000 divided by X. So there, that's just some algebra stuff there. All right. Now for part B, find the rate at which the average profit is changing. Rate, that's your rate of change, which is the derivative. Rate of change means derivative. All right, that will put the P bar. So the average cost is 4X minus 10,000 divided by X. But we want the derivative of that. Excuse me. So P bar prime. All right, now we're using the quotient rule, which is the denominator times the derivative of the numerator minus, now we swap them out, and that's all over denominator squared. Compute your individual derivatives. So the derivative of 4X is 4, minus 10,000 is a constant, its derivative is 0. The derivative of X would be 1, because 1 is the coefficient of X. And that's times 4X minus 10,000. That's all over X squared. Remove the parentheses. 4 times X. Distributing the minus 1 gives you minus 4X plus 10,000. Now, in the top of that fraction, the 4X and the minus 4X cancel out. Leaves you with your derivative. P bar prime is 10,000 divided by X squared. And let's see, the question said, find the rate at which the average profit is changing when 1,500 petunias are grown and sold. All right, so we want the derivative evaluated at 1,500. So that's going to be 10,000 divided by 1,500 squared, which is, I don't know, 10,000 divided by 1,500 squared is 0.0044. And like I said, I made the numbers up, so that's why it's kind of a weird answer. But that would be it. That would be the rate of change of the profit, meaning, I'm sorry, the average profit. The average profit is increasing, but by a very small amount. 0.0044 would be how much it's changing by. Okay. All right, so sorry I couldn't be with you for class today, but hopefully we'll get through this. And I am actually having office hours at the moment, so I'll be in my Zoom office today as planned, and I guess I'll see you back on Thursday. So we're finished with our material now. Thursday we'll do the review. Basically, the review is optional. If you would like to ask questions from the review that I posted on D2L, and it's up on my lab math. For practice only, it doesn't count your grade. I'll address questions on that and whatever you want to review. If you want me to just work a bunch of the questions, we can do that too. All right. I appreciate it, and I will see you Thursday, if not sooner. All right. Have a good day.